Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-5 Extra Practice Number 1 solutions on logarithmic equations. On this problem, to solve this logarithmic equation, I see that I have a single log on each side, so I'm just going to raise the base 18 to both sides. That's going to cancel out the logs, and I'm just going to have 11 equals negative 4n minus 10, which I can now solve. So let's see, add 10 to the other side, that's going to be 21. And divide that by negative 4, we have n equals negative 21 over 4. And just doing a quick mental check, if I plug this in for n up here, it doesn't look like, well, let's see here. This is going to be, negative 4 times negative 21 over 4. That would be positive 21 minus 10. That's not going to give me a negative inside a logarithm, so we're good to go on this answer. For this problem, we can start to get rid of these logs by raising the base 4 to both sides of the equation. So if I raise 4 to both of these log 4s, it's going to cancel out the logs and leave us with just x squared plus 22 equals negative 11x minus 2. Next, since this looks like it's going to be a quadratic equation, I'm just going to get everything over to the left side and see if I can factor this thing. So I'm going to have x squared plus 11x, and then this will be plus 24 if I add the 2 over here. Now, two numbers that multiply to 24 and add up to 11, that would be, let's see, we've got x plus 3 and x plus 8. That gives us possible solutions of negative 3 and negative 8. Now, if you plug these back in, you're squaring both of them in this first log, so that's not going to cause any problems because you're going to end up with a positive number. Over here, we end up with, let's see, 33 minus 2 is positive, 88 minus 2 also positive, so that's fine. So these are both acceptable answers. To get started on this problem, I want to isolate the logarithmic part of this equation. So I can do that by dividing both sides by this coefficient of 2. I guess I could also pop this in as an exponent, but I'm just going to divide by it. So that's going to give me log base 3 of b equaling negative 2. And then I'm just going to get rid of this log by raising the base 3 to both sides of the equation. So that's going to leave me with just b on the left side. And on the right side, I'm going to have 3 to the negative 2 power, which is really 1 over 9. Now, if I plug that back in, I'm not taking the log of a negative or 0. So this is a good answer. For this problem, to get to the bottom of this one, I need to have at most one log on each side. So on the left side, I need to combine these logarithms by dividing the things inside, since I'm subtracting the logarithms. So I can rewrite this as ln of 3 divided by negative 5x. All of that equals 5. Next, to get rid of this ln, I'm going to raise the base, which is e, to both sides. So that just leaves me with 3 over negative 5x on the left. And on the right side, I've got e to the 5th power. So to solve for x now, I'm going to start by multiplying both sides by negative 5x just to get that out of the denominator. And then I'm just going to divide by everything that's not x over on the right side here. So this is going to end up being x equals negative 3 over 5 e to the 5th. And just taking a quick check, if I plug this back in to the original equation, we have a negative times a negative is going to give me a positive, so I'm not going to actually be taking the log of a negative number. So I'm not going to have any undefined solutions that way. So we're good. For this problem, I notice that I have a single log on each side. It's the same log, so I can basically cancel out those logs or raise the base 8 to both sides. Either way, I get whatever's inside here. Negative 4x minus 9 equals 2x plus 9. And now it's just basic algebra solving for x here. Subtract 2x from both sides, that's a negative 6x on the left. Adding 9 to the right side, we have 18. So dividing by negative 6, we get x equals negative 3. Now you always have to check just to make sure you're not taking the log of 0 or a negative number when you plug this back in. If I plug negative 3 back in up here, this is going to be 12 minus 9, which is positive. That's fine. Over here, we're going to have negative 6 plus 9, which is also positive. So we're good to go with negative 3. For this problem, I want to isolate my logarithmic expression first. So I'm just going to add 9 to the other side just to get rid of that. So that's 2 over on the right side. And now to get rid of the log itself, I'm going to raise the base, which is 9, to both sides of the equation. So that'll cancel out the log on the left side. We'll have p plus 3. On the right side, we have 9 squared, which we know is 81. Subtracting 3 to get p by itself, 81 minus 3 is going to give us 78. And if I plug that back in, I'm not going to get 0 or any undefineds. So I'm good with this answer. To solve this problem, it would help if I had only a single log on each side at most. So on the left side, I can merge these logs together by multiplying the 3x minus 1 and the x together inside one big logarithm. So I can write this as log base 14 of 3x squared minus x. All of that equals 1. And now to get rid of the log itself, I just raise the base, which is 14, to both sides of the equation. So on the left side, I've got 3x squared minus x. On the right side, I've got 14 to the power of 1. And now this is a quadratic. If I solve this, I'll get my answer. So I'm going to subtract the 14 to get it over to the left, zero it out so I can factor it out. And this is going to be kind of annoying to factor. You could do guess and check, or you could use quadratic formula. I'm going to use the AC method just to show you that in action again. So recall, to start this process, you multiply the A coefficient and the c, the constant, here together. So 3 times negative 14 gives us negative 42. And then you're just looking for numbers that multiply to negative 42 and add up to this middle b value of negative 1. So that would be positive 6 and negative 7. So we're going to split this up into a negative 7x and a positive 6x in whatever order you want to write those. Next, we're going to factor this by grouping. So the 3x squared and the 6x, I can factor a 3x out of both of those, leaving me with x plus 2. And for these next two here, I can take out a negative 7, leaving me with also x plus 2. Factoring out the x plus 2, that leaves me with 3x minus 7 as the other parentheses. And now I can set each of these equal to 0 and actually solve for x. So x plus 2 equals 0, that means x is negative 2. And 3x minus 7 equals 0. Well, if you add 7 and divide by 3, you've got 7/3. Just double checking, if I plug in negative 2, that's going to make this second thing undefined, also the first thing. So we have to cross that one off. If I plug in 7/3, well, 7/3, let's see here, that would be 7 minus 1 and just 7/3 if I plug it in over here. So that actually works out in both of those logs, and we can use that as our final answer. On this problem, it would be a good idea to start this by adding the 6 over to the other side so that I only have just a single log on the left side. So we have log base 9 of x plus 5 equals negative 2. And then to get rid of this log base 9, I'll raise the base 9 to both sides. So 9 to log 9 is going to cancel out, leaving us with just x plus 5 on the left side. On the right side, I'm going to have 9 raised to the power of negative 2. So we've got, let's see, if we just subtract 5 from both sides, this is going to be 1 over 81 minus 5. Now, if you want to reduce this or simplify this, you have to multiply by my common denominator of 81. So this is really negative 405/81. And if I do 1 minus that, that's going to be negative 404 over 81. If I plug that back in, I know this is a little bit less than 5. So if I plug that in up here, I end up with a positive number inside the logarithm. So this answer is good to go.